Hi, I'm Lilian.
I'm Dominik.
And I'm Cynthia. We're from Apple presenting our experience report, Interdependent Variables, Remotely Designing Tactile Graphics for an Accessible Workflow. We worked on a project exploring how to make digital data visualizations like line charts and bar charts more screen reader accessible to blind people. But before we could start, we needed to figure out how to collaborate, especially on a visualization-based project as a team of blind and sighted colleagues. For example, to collaboratively brainstorm and evaluate ideas, everyone needed to access and reference the same set of sample data visualizations, and we needed to account for remote work during the COVID-19 pandemic. Taking the philosophy that accessibility is co-created and interdependent, meaning that it involves everyone on the team, we worked together to iterate on and make an accessible workflow for us to collaborate on our project. This experience report is a case study of how we developed the accessible workflow. In this report, we outline our process for developing and incorporating tactile graphics, share lessons and tips, and highlight some of the valuable impacts of making our workflow accessible.
Because everyone on the team needed to access the same data visualizations, we created ones that are both visual and tactile. While learning tactile graphics best practices from experts and online resources, we began by making handmade tactile graphics, as we can create them with low-cost, everyday crafting materials, like the 24 we're showing on this reference sheet. We used these and other materials to draw tactile lines, areas, and points, like with puff paint, glitter glue, different kinds of tape, and googly eyes. To make a tactile graphic, I, Lilian, a sighted teammate, first thought of how to simplify its content. For example, this scatter plot comparing penguin flipper lengths and beak lengths doesn't need to have so many grid lines to convey its main points, and tactile clutter affects legibility. Next, I made labels, both with printed text and with braille using a slate and stylus. After cutting and laying out the text, I drew the rest of the chart. We applied best practices for visual chart design to our tactile graphics. For example, I hand-embossed grid lines to make them tactily faint, to emphasize the data over the chart's structural components. Puff paint made bolder axis lines. Similarly, to represent data, I chose materials that feel distinct from each other, yet have similar tactile saliency to avoid giving one series unintended emphasis over another. After gluing on the text labels, I cut the top right corner of the paper to help Cynthia, a blind colleague, quickly orient the graphic, and slid it into a labeled protective plastic sleeve before shipping it and other graphics to Cynthia. This careful process and the protective sleeves kept graphics intact during shipping and understandable to blind collaborators to examine independently in their remote offices. To scale our operations, we invested in an embosser. After our initial overhead of choosing and learning to use our tools, here's the workflow we developed. I, Lilian, would digitally create graphics using tactile graphics software, which Cynthia would machine emboss. Cynthia then composed thorough feedback for me, with which we'd iterate on the graphic. Using an embosser really helped us to not only iterate on and modify charts, but also to create multiple copies to mail so we could include more blind and low vision collaborators in our workflow. We'll note that some charts still work better as handmade graphics, like this heat map, which uses 3D topology to represent its color scale.
When our team discussed ideas, we frequently referenced our tactile graphics. Someone would share the title of a graphic that conveys a concept, and I, Cynthia, would pull out the tactile version while sighted team members looked at its photo. Using tactile graphics made a significant difference in participation. Everyone had the opportunity to follow others' observations, ask for clarifications, and contribute ideas. We couldn't have done that with alternatives like data tables or verbal descriptions. Take Anscombe's quartet, for example, 4 sets of data that have the same simple descriptive statistics like mean, correlation, and line of best fit. Finding patterns using numeric tables would take a while. But with graphics, like the handmade ones we're showing here, patterns become immediately apparent. The 4 charts look very different. Points scattered vaguely around a line of best fit, points in a neat curve, all but one point in a straight line, and all but one point overlapping the same X value. The benefits of making our workflow accessible were invaluable. I, Cynthia, and later other blind and low vision collaborators used the tactile graphics to help us initiate, contribute to, and change important project decisions. Making accessibility part of our culture and treating it as a shared responsibility also made the team more welcoming and inclusive. We encourage everyone to treat access as a collective responsibility and make sure it is supported with necessary resources, infrastructure, and recognition. We recommend more research on incorporating accessibility into workplace processes and cultures, so the labor does not remain invisible and overburdened onto disabled colleagues. Thanks for watching.